Martin Saleteg, thank you very much for joining us today.
Thank you very much.
How are you enjoying ADC?
So far it's been pretty good. Eye-opening for us, I must say.
Mm-hmm.
There are many topics we have to improve upon within the company, and every time we come to the ADC, we always get a lot of great ideas. And it's also a good time for the team to get together.
Excellent, excellent. So, how do you describe what you do for VSL?
Oh, yeah, that's kind of difficult. I'm in charge of software at VSL, so I lead our team of software developers, and I'm the lead developer for many of our products. And that includes everything from product ideas to the final implementation, really.
Excellent, excellent. And how long would you spend roughly developing a product from those initial ideas to release?
I mean, it depends completely on the product, of course. If it's something massive like Mir, which you know about, it takes a long time. That product started as a research project, which I wasn't involved in at all. So, I mean, if it's a smaller plugin, it can take a couple of weeks to go from idea to finished products, really. But for the bigger things, it's kind of an evolutionary process, I would say. So we start somewhere and then we build upon it, and especially with the instrument software that we have that keeps on getting new features every month or something like that, and silently being included into the software, and we just make it better.
Yeah, and also the expansions, you have room expansions as well, don't you? So you're creating sort of new spaces for the software as well.
Yeah, we have a team led by Dietz, who's the inventor of Mir, so to speak. And he's making new room packs every now and then for the Mir product. And this then we bundle it up in certain constellations and sell them as additional packs. Yeah.
Excellent, excellent. And I'm interested to know what got you into programming. Like, what was your first sort of exploration into programming?
Oh, that has nothing to do with music whatsoever.
Yeah, well, that's fine. What was it for?
I first got into programming at the age of, I think I was 15, and me and a buddy of mine, the same class as me, we started developing a database and accounting system for a relative of mine he's running a large amount of traffic schools, like driving schools. Wow. And they didn't have any software which was really specific to them. So I started building this thing, and then we started pitching the software to other driving schools around in Sweden, and went on tours to try to sell the software and so on. And we managed to sell a couple of copies.
Great.
But at the time of 15, 16, it was really interesting for me. It was a fun project to do for sure. Even though it was like Visual, what was it called back then? Visual Basic for Access. It was like a Microsoft Access.
Oh yes, I remember Access. Yeah.
Yeah, that's a long time ago.
Database program. Amazing.
It was fun. It was fun.
And when did that cross over? When did your programming cross over into like the audio world?
So after doing this stuff, mostly during high school, then I went more into audio engineering. So I studied audio engineering, and I was working as an audio engineer for quite some time. And then I started studying some business, and at one point, I just had the feeling that actually I don't want to do just audio engineering. I'd rather do tools for audio engineers. And that's when I got back into programming again. I'm picking up the audio engineering side of things, started to create plugins and so on now.
Great.
And
in terms of starting off with VSL, when did that happen? When did you...
I think it was like Me and my best friend George Young, we wrote a sample rate converter software for VSL back in 2002 or something like this, or 2003, and yeah, that was the first thing we did for VSL. And then I think 2 years later, they came back to us and asked if we were interested in doing virtual instruments for the company. And yeah, we said. We had already been working on a couple of virtual instruments before that. We had kind of a basis of a sampler engine and so on. So we continued that process with VSL. It was a good match at that time.
Excellent,
yeah.
Excellent. Cool. And of course, you've just released in collaboration with GPU Audio Vienna Powerhouse. Yeah, it'd be interesting to know, like, when did you at VSL recognize the need for this kind of acceleration?
Oh, it's quite a long time ago. You know, we released the first version of Mir back in 2008, I think, at the Frankfurt Musikmesse.
Oh yeah.
So at that point, it was really like its own standalone application where you could load audio files into it and play it back inside this room. And of course, the computers were very limited at that time, so you could only run a couple of tracks. Already at that time, we saw that, okay, we have to do something else here. And we waited a little bit for the new CPUs that were coming out at that time. I think that was just when Intel switched to the core architecture. And so when Intel released those, we saw, okay, is this actually possible to do something proper with this? And then I think at the NAMM show in 2009, that's when we really had something which was rather performant, and then we made it into a product where you could put your virtual instruments inside of it and so on. Already back then, like say 2010 or so, I was thinking if we should go into the direction of doing something with on the GPU. There were some early attempts on doing this, and a lot of white papers and research on this topic just around 2010, 2011. But I think the technology at that time was too immature to really go all the way. You had huge issues with latencies in shuffling data back and forth between the GPU and the CPU. And I remember the first attempts at making like convolution reverbs on the GPU. They were quite badly performing because of those. Like it was really better to run it on the CPU. You had less CPU usage by running on the CPU than the GPU, and it didn't make any sense at that time, right?
Is that because the CPU is controlling the operation of sending the data to the GPU?
Yeah, you're
why
always waiting for something. And yeah, the overhead was just too big. It was okay to do things offline, but whenever you want to do something real time, oh, police is here. Whenever you wanted to do something real time, it was really difficult. So we didn't really pursue that route at that time. It was only really last year when I met up with Sasha, and I saw that this could actually work out. We for ourselves we don't have any developers who are experienced with working with GPUs, like any game programming experience, so we just don't have in the company.
Yeah.
So we would have to either get some external developer in that has experience with that, or we would partner up with a company like yours. Yeah. So I think that was a pretty good decision from our side.
Yeah, I think it's been very well received. You know, a lot of the comments on the release last week were very positive about the technology. Yeah, people are already asking about Synchron Player and other VSL products that might be supported. Where do you see the future of the GPU acceleration for VSL? Like, where do you see it going in the product range?
Like you mentioned, synchron players, like that's going to happen because we have a lot of our instruments which are based on large amounts of convolutions in there. And at the point where we are right now, we're mostly looking at offloading processes which are, let's say, self-contained and complex. And that's, I mean, convolution is the ideal thing to run on the GPU because you need a ton of fast memory access. And it's inherently parallelizable, realizable on the GPU. We have some plans for some other things on the GPU as well, for other products. I cannot really tell you too much about it right now, but it involves very large parallel models, physical modeling, stuff like that. But sure, we're looking forward to seeing where let's say where we can take advantage of the extra power right now.
Yeah, absolutely. Yeah, I suppose that leads a little bit to whether you have any dream software that you've always wanted to make that you haven't been able to realize, maybe due to CPU limitations, and what's been holding you back from achieving that kind of design?
Well, that's such a difficult question. Really, you showed me this question before, and I was like, whoa, what the I don't know, really.
Yeah, I guess what really, I guess it's based around the fact that in development you're kind of you're always developing with CPU limitations in mind. So yeah, maybe if those limitations didn't exist, is there anything that comes to mind that you would love to achieve?
When it comes to our orchestral software, which is what we do, I'd say I would love to take away the complexity from the user and simplify things, but really having everything under the hood being automatically controlled by AI. So my dream software would probably be an AI-controlled virtual orchestra where each individual player within the orchestra is controlled by a human-like AI that creates all the minute, tiny variations they have within an orchestra for it to sound actually human. That's an ambitious project, especially to try to combine it with samples. Perhaps you have to go a different route. I don't know right now, but it's something that could be interesting to explore.
Yeah, because I think from a performative side, you could almost give that sound source a personality in the way that they play. Yeah. It's not like not just the tones that they're playing, but
what they had for breakfast.
Yeah, exactly. Yeah, where what influences they had growing up, things like that.
Yeah, that's true.
Super incredible.
We actually went. I say we did this series of product called the Dimension strings, Dimension brass, and so on. And there we recorded individual samples for every part in the orchestra, in the sections, and they were recorded in unison. And we did introduce a lot of humanization factors, but they're kind of algorithmically based, so you really change the timing and the intonation and the tuning for every note separately. Mm-hmm. You do have control over that stuff, but what I would like to do is not to manually have to control that stuff, but actually that you would have a virtual brain that actually takes care of that in the background. And I'm sure it requires a ton of training data to get there, of live playing orchestras, but it's definitely something we could explore, I think.
Exactly, and also I'm thinking in terms of synthesis, where you have like a swarm control. Let's say you've got sort of 100 oscillators, and you've got a swarm control which kind of generally controls the hive of them. Yeah, that would be a really interesting thing to work with, like a collective control that's kind of AI that's...
Right.
They are individuals, but they're also group controls as well.
Yeah, and what you want is actually to have the control that the conductor has in the orchestra. Yeah. So you just control that group, but individually they interact and they get these vibes going. That would be really cool to mimic in software, I think. Excellent.
Yeah, and what sort of challenges did you overcome implementing this GPU processing for Vienna Powerhouse?
We had quite a lot of challenges in the beginning, getting this project started. I think mostly it was related to scheduling, to get the graphically intensive applications like Mir is. It's inherently a 3D application, so it's going to be competing with the audio part. And I think getting that right was probably the most challenging thing. These days, like you especially have on Apple Silicon, and like Apple Silicon, they changed from this uniform core strategy to use like E cores and P cores, and to ensure that your processing on the GPU is only performed on the P cores versus the E cores. That was quite challenging to get right. I think that the same, we'll start to see the same thing happening on Windows as well, because Intel has also gone the route of doing efficiency and performance cores. And right now there are no really good ways of handling this, and Windows has a lot of limitations per process when it comes to thread management, which you don't have on the Apple side. And say Apple already has a couple of ways of how to get around this stuff. But on the Windows side, that hasn't been developed so far. And we're talking to both Apple and Steinberg and other involved parties to get this stuff working now.
Yeah, so just in terms of coming up for VSL, like what's the next what are the next few months looking like for you? What are you going to be working on?
I think we have a couple of things that we want to do with the Vienna Powerhouse right now. Like we discussed about synchron players, synchron pianos, and so on. See how we can leverage that in the best way, and then we also have some homework to do in the AI department. I think that's going to be the next couple of months for us. Yeah.
Absolutely. Great. Well, thank you very much for speaking to us today.
Well, thank you. It was good.